Good morning, everybody. How's everybody doing? I'm surprised to see so many people here. I thought most people would still be asleep from the great event last night. Cool. Okay. Does it compile? Does it compile and run? Does it compile and run correctly? Does it compile and run correctly and quickly? Does it compile and run correctly, quickly, and securely? On XYZ device or agent, in ABC region or location? Can the development team make changes easily? Can it be debugged? Can it be extended? Can it be scaled? Can it fail gracefully? Can it self-heal? Can we answer all of these questions immediately and with determinism? How can teams of humans most efficiently and effectively build and use tools to answer these questions and more? This is the infinite reality of our work to be done in our field. In short, the world of quality engineering encompasses a large and ever-growing swath of specialties. A recent surfing safari of mine has been in security, which I consider to be a sub-area of quality. I'll share my adventure riding this wave, what has worked, what has not, why, and invite you to do the same. When I was hired approximately 2 years ago at my current company, the task was to build a software engineering group focused on shipping high-quality, highly secure libraries, services, and frameworks designed to make security achievable for the larger software engineering organization. In this way, the engineering team could stay focused on customer acquisition, product, revenue, and profit, and simply make a call to one of our APIs or security flows, or one of our libraries for whatever they needed for common security flows and functions. My organization was called Security R&D, and we were composed of teams of developers within the larger security group. This was the strategic approach that we took to dealing with the chaos that had developed in our code base. So starting from scratch, I hired about 70 folks, including full-stack engineers, front-end developers, iOS and Android engineers, data scientists, designers, product managers, and a management team which spanned 4 entities. When you're growing so quickly, an obvious focus must be on hiring and retaining, both of which center around culture. This is a whole separate presentation that I'll be giving in just a few weeks at another conference in San Jose, so stay tuned. But I'd just like to mention quickly some of the cultural achievements for my organization. I believe that it is obvious that strong culture means stronger delivery, higher quality, higher security, and more impactful results. But I also have data to prove this is true. There was a cultural survey sent out in the fall of 2016 across the entire company where I work. My organization had the best cultural ratings. We were anomalously high. We were also the most diverse engineering team across all metrics, including gender, ethnicity, sexual orientation, age, and even background and technical expertise. We launched a flagship program called the Apprenticeship Program, which was a gateway for talented, hardworking people with non-traditional technical backgrounds to enter into the company. We launched a program called Boost to help people reach the next level of efficiency for optimal work with meditation and focused work. I also led and volunteered for a resource group called LadyEng, and while leading LadyEng, our group sponsored our first public technology conference, providing many talented engineers professional coaching for public speaking and the opportunity to share their incredible work. And I also represented our company at Grace Hopper in 2016 as a panelist. So all of these things matter a lot when building a strong team, whether it be in security, in quality, or any engineering field. But back to the subject at hand. What is software that is of interest to security? It is anything related to the art and science of keeping secrets. Of course, this relates back to quality engineering, which is holistically concerned with, does it do what it's supposed to do? To give you a better sense of what I mean when I say software which is of interest to security, here are some core concepts which we like to reason about collectively. It's collectively known as the information security triad: confidentiality, integrity, and availability. We see mechanisms that impact one or more of these goals with tools like cryptography and access control, and the system design concepts of least privilege, separation of concerns, rotation of duties, prevention, detection, disaster recovery, and graceful failure. I would argue that all of these system design concepts are important pillars in any high-quality software product, and that an excellent quality engineering team would ensure these were in place. Core user flows which are of interest to security include identification, authentication, and authorization. Identification is simply declaring who you are. Authentication is the idea of proving that you are who you say you are. Typically, authentication is done with either what you know, for example, a password, what you have, for example, a YubiKey, or what you are, for example, with biometric authentication. Authorization is the process of identifying what rights you have to take certain action on certain resources. Essentially, now that we know who you are and you can prove it, what can you do with a given resource? Can you read it? Can you change it? Can you delete it? Can you share it with others? Of course, all of these would be primary flows under review in any quality review. Much of the work we do in security, and of course quality, relates to how we handle data. In particular, data deletion, data filtering and sharing, and of course, data encryption. I'll talk in more detail about core user flows and core data functions in my recent work in these areas now. And then I'd like to step back and consider the parallels in security and quality, and why you might like to consider a shift into this specialty as general quality engineers, why you might not like to, there's some cons, and steps you can take as a vendor or as an individual contributor if you're interested. So for background on the company I've been working with, since the time I started, over the course of 2 years, it has grown from a startup of a few hundred people to over 12,000 full-time employees, with roughly half of those people in engineering. And even now, I would describe the technology state to be in a kind of teenagehood. We are no longer a young company, yet we have not grown to full maturity in terms of our engineering stance, though we are trying hard to get there. Because of the growth rate, each month feels and felt like a new job to me. Visionary thinking and strategic planning was critical, and we made many correct decisions and some incorrect ones. One of the biggest questions we had to answer was what to do first, when there's so many things which could be done and need to be done, and only a limited amount of people to work on them. How do we pick the right order of work? And I know this is highly familiar question to people in this room. So in general, these steps served me well. First, understand the landscape. Observe, listen, review, and study. And this was a lesson that I had to learn the hard way several times in my own career. It's really important to understand first before you start work. A common mistake that people make here is to dive into the first solution they find without appropriate understanding ahead of time. And a manifestation of this is to simply do what the customer is asking for. The customer understands the problem well, but not necessarily the best solution. Then you need to understand the greatest need, which means that you need to be able to prioritize and basically map out the project in terms of cost and reward. So if you're looking at the x-axis in terms of cost and the y-axis in terms of reward, you want to work on the projects that are in the upper left-hand corner. And you need to follow the 80-20 rule, because you should assume that 80% of your work will result in 20% total value, and 20% of your work will result in 80% total value. and you need to optimize for doing the 20%. And this is, of course, I think, a core principle to approaching quality engineering with Selenium testing. So after spending a good amount of time going through the exercises I just described, we decided that customer authentication was the area to focus on first. To give you a sense of why, at this point in time, we had developed a microservices-based architecture with tens of thousands of RESTful APIs. This had developed after a major effort done some years earlier to move away from the monolithic architecture that the company had started with, which had threatened to topple over once we began to see exponential growth. So we had survived the transition from monolith, but now we had many new and exciting challenges to deal with. One of the common issues with this design was multiple implementations of the same thing. In the case of customer authentication, we had something like 10 different implementations for various products. And each of these implementations had its own set of logical bugs, performance problems, maintenance costs, and security vulnerabilities. And at the time, we had serious losses from fraud, as well as account takeover problems, both of which were possible due to known vulnerabilities in some of these implementations. So it felt a lot like a game of whack-a-mole. So due to all of these issues and more, we decided to build a single, extremely high-quality, highly secure customer authentication platform, which would power all of the needs of the business in one place. When designing our new customer authentication platform, we began to define our requirements. Of course, it had to be secure, and it needed to protect our users' identity and defend against defrauding the company. It needed to be an implementation of best practices and embody state-of-the-art security and privacy. And it needed to be a strong foundation to support the entire company ecosystem, including services, APIs, and third-party developers. Usability was a major concern. Systems which are secure but not usable result in people finding a way around such systems, rendering the effectiveness of the security attributes worthless. I would go so far as to say that any security system which is not usable is not secure. Specifically, we wanted to reduce friction during key user flows like sign-up, login, account management, password reset, and reduce customer support costs due to an unstable authentication process, as well as improve our brand trust due to account takeover. Of course, the platform needed to be scalable and maintainable, and specifically, we wanted to eliminate any trip failures due to authentication failures, which unfortunately at the time we had a significant percentage of these. We wanted to support 10x user web and mobile login requests and just reduce the overall maintenance burden within engineering. And finally, it needed to be extensible. We knew that authentication methods, which were culturally understood and accepted in Beijing, would be different than those in Stockholm, and yet different again from those in New Jersey. We also understood the need to integrate with external identity providers and third-party APIs and other businesses. So we divided the project into several smaller projects. The first was user login, which was composed of the login UI, the login and logout flows, third-party sign-in, multi-factor authentication, and passwordless flows. The second area was integration of edge services to the engine and integration of downstream services to consume verified identity, essentially a caching middleware. The next area was third-party client authentication via company users. For example, the flow of first getting user authorization and then allowing calls into the company API. This was built with OAuth 2, an OpenID Connect server, client and scope management tools, token validation and revocation logic, a client SDK, and of course, a playground environment for testing. Very important. The fourth area was composed of anomaly detection and monitoring, and the fifth area was focused on user control and visibility, which would support user flows like change password, account recovery, view connected apps and disconnected apps, configure login and second factor authentication, view login history, and report account takeover. Here's what the architecture looked like from a high level. It's simple, right? You have a customer presented with a login challenge handled by an authentication provider, which then transmits an internal token to an edge server, which is then propagated to downstream services. Or that customer can authorize a third-party service to delegate authentication on their behalf. So as of now, the final legacy implementation of customer authentication has been migrated onto the new platform, which is extremely exciting. And we see tremendous improvements in user acquisition due to the reduction of friction in signups and user flows. We've also maintained an uptime and SLA of 4 nines, which is outstanding. And we've seen measurable performance improvements, as well as reduction in hardware and compute costs. We've also shown significant reduction in losses due to fraud and what appears to be the complete eradication of account takeover. And finally, we observed the ease of onboarding with new services and platforms. So this was sort of our flagship project for 2016 that I'm extremely proud of. But second to authentication, in terms of priority, we also had to deal with privacy, and specifically data deletion and data filtering. Data deletion may sound easy to some folks, but it was a challenge for us. So at my company, we have basically every conceivable data store that exists in the world deployed in one way or another, as well as primary and secondary and tertiary propagation of data. So you can imagine how little people were thinking about privacy and the ability to truly delete data as they were rushing to ship features to keep the business afloat, or refactoring the code base to avoid a complete system shutdown due to ever-increasing load. Unfortunately, I can't go into the details of how we built the solution, but I can say generally that we tackled this problem with a system which allows storage teams to integrate with and register with our deletion engine by implementing some required actions and thus becoming deletion certified. Our engine would schedule deletions after first checking with our legal authority and then repeatedly test that the data was in fact deleted after the fact. And this was a key function for us because once you delete data, it sometimes can reappear magically. So the repetitive testing was key. The strategy after onboarding our primary data stores was relatively straightforward. Migrate or onboard the next round of data stores until all have been certified. Another area of importance for us was data filtering and the ability to share data internally and externally without compromising individual privacy. This is a view of a tool that we have internally, which allows employees to query whatever they want from whichever data store they want, and it's critical for business operations. Our challenge here was how to make sure that our users' privacy was being respected and safeguarded against insider threat, that was also done in a way that was compliant with stringent laws coming from the EU. And it's not just internal filtering, but also external data sharing. For example, we recently launched a tool for city governments and urban planners, which shows detailed traffic patterns. But it turns out that with raw trip data, there are serious privacy risks. With just the raw trip data, it is trivially easy to identify who you are and where you're going. And once I know who you are and where you're going, I can now infer a great number of things, including political affiliation, any medical conditions you may have, if you're having an affair, of course, and many other things. And so obviously we couldn't share the raw trip data directly. So in order to deal with the risk of individual de-identification from trip data, we were either forced, or data that we were forced to share due to sort of government rulings, or that we wanted to share with the research community, we developed a filtering technology which implemented several kinds of filters, including the ability to use something called differential privacy. Differential privacy is a bit more complex than simply obfuscating a certain data field. It has to do with the nature of the data set in its entirety, as well as existing data sets which may already be in the public field. Here are some historic examples demonstrating the risks with differential privacy, or the risks that we're trying to defend against with differential privacy. So one of the earliest and most disastrous was at AOL in 2006. A research team there had wanted to do something good and share some of their search data with a larger research community. So they published 3 months of search terms. Of course, they didn't publish any individual data directly, such as name or username. They did, however, use random IDs, which were assigned to the same user consistently. After releasing the data, within a matter of hours, many individuals had been de-identified due to self-referential search terms and the random but consistent user ID. AOL promptly removed their posting of the data. However, it had already propagated through the internet and is still available to this day. The result was profound and included the resignation of everyone involved in the project, as well as the management chain, all the way up to the CTO. And some search terms prompted legal investigations, which begins a whole separate discussion on the proper law and punishment for thinking about a crime, planning a crime, but not yet committing a crime. But that's an entirely different talk. A second example, more recently, can be seen from 2014, when a data scientist named Anthony Tokar mapped celebrities with New York City taxicab dataset. He used the medallion numbers from celebrity photos and the government-collected taxi trip data to make correlations and determine which celebrity was going to what whorehouse and stuff like that. In this case, government rules demand that trip data be public and shared with anyone who requests it. However, this very data was used to infringe on privacy rights. Government right to information acts awfully directly conflict with privacy laws, and the answer to this problem is still unsolved. And of course, the third example of this kind can be seen when researchers partially broke the presumed to be anonymous Netflix dataset by cross-referencing movie data with the IMDb database. So differential privacy attempts to safeguard against these risks by providing a filter which, when asked about a collection of data, will still return the same statistically relevant answer, but will perturb the data just enough so that individual de-identification is not possible. The idea is that for a given function f, the output should be the same with or without the inclusion of data results from a single individual. So in terms of how to achieve differential privacy, the approach is to add random noise, which is scaled to a query's sensitivity, where a large data set will have a low sensitivity, and a small data set or query which results in data about a single individual, for example, will have a high sensitivity. I can't go into the details of our solution here too much, but generally speaking, we built a framework for data filtering which supports all of these use cases. There are different plugins which can be activated, including simple data obfuscation and region or location limitations, as well as differential privacy filters, which modify the query at runtime in order to perturb the result set properly, rather than modifying the result set after it had been retrieved. We first made that mistake and then fixed it. And we're able to do this with knowledge of the schema and some details about number of records ahead of time. And so a third area that we focused on in 2016 was related to authorization. Authorization and which services and users have access to what data is particularly hard when you're dealing with a microservices-based architecture. And authorization choices and logic have sprung up in the application layer in an inconsistent way. What this typically means over time is that an authorization devolves into sort of a fail-open model where anyone who is part of a given LDAP group has authorization rights, and it just so happens that every single person at the company is part of that LDAP group. What we discovered is that the ideal authorization model is one where decisions are made at the data layer, or as close to possible as the data layer. So here's a simplified example of best practices for the data authorization flow. So imagine a service requests to write data, and then the data is allowed to be written. How should it work? To write data means to create, update, and delete it. So in this diagram, we see service A as the front-end service. Service A calls service B calls service C, and service C accesses resource in the data store via our storage library API. We begin by injecting the actor context into the running process with our implementation of the Java Open Tracing API at the edge service, service A. So context propagation propagates downstream as service A calls service B and service B calls service C. Each service has a context propagation policy, lots of Ps, for example, create a context from the request and inject it downstream, or pass the incoming context as is, or append a service context and mark it as primary, which might be needed in the case of impersonation or privilege escalations. The storage library checks the actor context sent in the incoming request. If there's no actor context, it will deny access. And if actor context is present, it will extract the context from the request and then call the authorization engine, which will then make a determination and return the authorization results. These results are either deny or allow and are determined based on policies which are copied and stored locally with the running authorization process. And a deny result will throw an unauthorized exception. If the response is allow, then the storage library allows the operation to proceed to the data store and return success. The same flow is done for read operations with some additional pre- and post-processing steps. With the first request, we add a random one-time number, also known as a nonce. If the authorization request is deemed to be allowed, the result which is returned is signed with a nonce, along with a number of other things. Upon getting the response, the edge service expects the actor ID, random nonce, and some data about the signer to be returned in a signed form. This verifies that the applier of the authorization policy is a trusted entity and prevents the signature from ever being used by a caching layer. This is required to verify that the user has been honored in authorizing the particular request and no response was served from the cache. And as I mentioned, we suggest a policy management service which is responsible for policy specification and management. It should be responsible for distributing policies that are stored in a central place, but sent out to various data stores so that they can be stored locally, again, for sort of caching reasons. So now that I've shared some details in my recent work, I hope I didn't bore you guys too much. I'd like to take a step back and talk about state of the world of security, why you might like to consider it, why you might not like to, what you already know as quality engineers that are highly applicable skills, and how to get started as a vendor or as an individual contributor if you'd like to transition into this area. So the strip of beach I've been swimming in is what you might consider to be described simply as application security services. But in terms of risk and volume, phishing is still the largest and most successful attack vector at about 70% of known attacks. With application vulnerabilities at about 20% and network or system vulnerabilities at about 10%. And across these domains, there are 30 to 40 insecure patterns we see time and again. 5 or 10 of these can't be fixed with technology, unfortunately, because they're due to people. But these can be addressed with training and education for people to learn proper behavior. So most companies defend against risk in one of three ways. Either they have no sense of cybersecurity, and everything is default open and highly insecure. In this scenario, the productivity of the development team is of utmost importance, and everything else, including security, is deferred, which is common for many startups. And this situation can be true of quality as well. And I call this completely open. Or they can swing to the opposite extreme, where security organizations are given ultimate veto power, and the answer to any change needed for innovation is no. Larger enterprise companies tend to exemplify this state, and I call this state completely closed. And with a lot of care and time, these companies may finally arrive at maybe, if you fill out these forms and wait for 2 years, manifesting the epitome of bureaucracy and what I'd call completely slow. And basically, all of these methods are wrong and represent a form of corporate failure, in my opinion. But I think that there is a fourth mode that could be successful, which I like to call completely dynamic. And like, for example, let's take the use case of internal access control. How do we manage which employees have access to which data? As I mentioned already, the startup would say, everyone, just let the developers ship code. The enterprise company would say, no one, developers can wait, risk of any incident is too high. And the slightly more mature company might say, only people in this LDAP group, but in order to be added, you need to first file a JIRA, wait for 2 months while it's being processed, reviewed, and approved, etc. What we instead want is what I believe was at the core value of Selenium and what caused it to be catapulted into testing as a disruptive technology 10 years ago, which is automation and efficiency. And we want a dynamic learning system that doesn't require intervention by humans or code changes by developers very much, but rather looks at normal behavior pattern of people in similar roles and gives access to the individual accordingly and in a changed way over time. So there's much work to be done to automate security functions in an intelligent way, which I believe could be of interest to people who have already automated quality functions in an intelligent way. If you're interested in moving to security, there are a few important milestones to be aware of, just in the evolution of how things happened. So basically, all encryption requires a key of some kind to decrypt with. And during the early days of cryptography, this key would be transferred among those wishing to encrypt and decrypt messages in person or through a separate channel, which introduced a lot of problems, obviously. Most of these problems arise from the chicken and egg situation, where you're trying to send a secret message by first sending a key without having the means to secure the communication. This problem was, of course, solved with the genius invention of public-private key cryptography, where essentially you just give out locks to everyone, but you keep your own key to unlock them. Important concept to understand. More recently, another major milestone happened, actually, with the creation of something called perfect forward secrecy. So even public key cryptography is only as safe as the safety of the private key. If the private key is compromised, all messages sent previously can be decrypted. And this is a single point of failure and violates the defense in depth principle, often cited as one of the primary tenets of best practices in security. So in 2004, Open Whisper Systems developed an implementation of this, which has been used in Google Chat as early as 2008 and Facebook's WhatsApp, among several other chat systems. Perfect forward secrecy means that the encryption system automatically and regularly changes the keys it used to encrypt and decrypt information. This means that if the latest key is compromised, it exposes only one segment of the user's data. And keys can be switched on every message, for example, in text-based conversation, for every phone call, in the case of encrypted calling apps, or every time a user loads or reloads an encrypted web page in their browser. So that is my 10,000-foot view of important milestones in security and the state of the professional security world as I see it. So now let's talk about the fun part, which is why security. So for me personally, my childhood dream was always to become a police officer. I don't know if anybody knew that about me. And to do right in the world, and to protect those who could not protect themselves. And I feel like this image, for some reason, captures that. I'm not sure why. So that same instinct was what drove me to quality. And working in security is a kind of embodiment of this dream, of making the world a better place. So I'm circling my childhood dream with a new lap. Of course, there are other reasons like luck and happenstance and people, but this is what called to me in the deepest sense. Both quality and security aim to protect the developers, the company, and the users, and this resonates deeply with my purpose here on Earth. Another interesting thing to understand, though, is that the market demand for security work is growing. A random sampling of Hacker News reveals somewhere between 20 to 50% of all top posts are now related to security. For example, from this date, sometime in March, we see these posts. Lifetime of cryptographic hash functions, announcing the first SHA-1 collision, list of sites affected by Cloudflare's HTTPS traffic leak, using ordered Markov chains and user information to speed up password cracking, lessons from the history of attacks on secure hash functions, Linus on Git and SHA-1. And to compare this with other specialties in quality, I don't see any post for this date and rarely see these over time. Because demand is increasing and supply has not caught up, there are more jobs with better pay in security as compared with other types of quality work. The typical increase in compensation, which I've seen, is 2 levels up. So if a general quality engineer at level X receives Y compensation band, a security engineer at that same level X receives compensation band at Y plus 2, mostly due to the incredible deficit in security professionals and difficulty hiring. It's hard to quantify lack of a negative. If there are no major logical bugs released to production, does that mean that the quality team is doing a good job or not? If there are no major security vulnerabilities, does that mean that the security team is doing a good job or not? Because of this fundamental inability to quantify, a lot of freedom in your work can be granted to pursue the areas that you feel are most important. I think this is true of both security and quality. And like quality, everyone wants security, yet there is no silver bullet. And like quality, there are meaningful ways to improve the security, health, or posture of an organization. And like quality, we focus on process and automation for effective results. So I've talked a lot about the upsides of working in security, but security does have its downsides too, and some of them will sound very familiar to generalized quality engineers. The first one is that there are a lot of nonsense products that don't work well. Similar to what you might find in quality, but more so. In particular, many tools result in a high number of false positives, which, as we all know as Selenium experts, basically reduce the tool value to 0. And the other thing is that many of these products have a lot of dark and red and black wavy icons that are annoying, so that's also a negative. There are a lot of products that run slow, like a badly deployed installation of Selenium tests, and therefore can't be included in the developer workflow, and therefore have lost the majority of their value. This is something we understand. And security shares the same aspect of quality in that many times people are hired for the sole purpose of being available to blame if something goes wrong. So there is that sort of shared scapegoat problem. The stakes can be higher. When things go wrong, they go really wrong. And usually this is in the form of money lost. But in truly dark situations, this can impact human safety and human privacy, which cannot simply be repaid. So now let's talk about things that you already know. There are a lot of things that you already understand, which are highly relevant to security engineering. The truth is that security is a subgroup of quality, just like performance, usability, and many more areas. So successful security work is interwoven into the development process, as is successful quality engineering work. And we all know this very well. And thus, we aim to insert security tools and reviews from the beginning to the end, including during product design, in the creation of the RFC, during active development, once the product is done, and after it has shipped. Like quality, security specialized reviews done by humans requires ruthless prioritization. This is a highly transferable skill. Given 100 requests each week, only 1 or 2 are selected, and 1% of all code is audited. For the rest, we just accept the risk. We're never able to find all the vulnerabilities or bugs. We accept lots of trade-offs, especially with fraud. It's just money. We accept fewer trade-offs with things like privacy and safety, which cannot be refunded. So now let's talk about what next, and how to begin as a vendor, for example. I think, personally, that Sauce Labs could probably double revenue in less than a year if it were able to offer a simple additional security screening service along with its testing platform service. Making add-on products that your existing customers want is sort of always a no-brainer. We did this recently at my company by shipping a food delivery service. And it's growing like gangbusters and may even replace our primary product as the lead in profit and revenue. It turns out that people who don't have cars and need rides to get places also want food and would like to have it delivered. Sauce Labs could expand its product offering to target not just quality managers, but also security managers, who, by the way, tend to have more budget and influence in the organization. And the technology needed for such a feature would be minimal and could piggyback on the existing infrastructure and the awesome platform that Selenium is. ApplyTools actually started off as a security product, if I'm not mistaken, which highlights the cross-section of quality and security, and the possibility that tools which we use for one can also be leveraged for the other. And any new startup working in the quality engineering space should take advantage of the fact that security tools have historically skewed toward IT rather than to the developer workflow. There's much ground to be broken with tools that would allow developers to identify and fix security vulnerabilities during the development process rather than as an arbitrary process used once the product is shipped. So now let's talk about how to begin as an individual contributor. There's so many great resources available these days. Here are some of the ones I recommend to start out with. And I remember when I started learning how to program about 20 years ago, there was nothing like what exists now. And I remember my experience was sitting in front of the computer and staring at the screen and crying, and then starting over and trying again and staring at the screen again. But people don't need to go through that anymore. There's all this stuff to help you now. So check out these tutorials. For folks who are curious about sort of incident response and investigation, here are some of the tools that we use that I recommend that you can become familiar with if you're interested. So basically, so much of what exists today is IT-focused rather than developer-focused. And we need more developer tools for security. And quality is ahead of security in this way. And I hope that we can see more cross-pollination between the two groups. Turns out this is one group who's already started to merge the two. They're based in Europe, and they're actually using Selenium to power some of their system. I encourage you all to reach out and get involved in this project if you're interested, or to start one of your own. Thank you very much. Where's Dave? Is there time for Q&A? How are we doing on time? We have 6 minutes. Does anyone have questions? Comments? It's still early. Why did we start at 9? We should have started at 10. Well, it's, yes.
Yeah, so
Yeah, so the question is, how long did it take to hire and build the team and to actually ship the product? We spent about 10 months building the org. So in month 1, it was like 5 people, month 2, 10 people, month 3, 15. So it's sort of a rapid growth pace like that. One of the things that we did, which may have been a mistake, but at the time felt like we had to do, was sort of take ownership of a few of the existing implementations of systems for authorization, authentication, and privacy. And it felt like we needed to do that in order to sort of gain credibility within the engineering group. But it also kind of slowed us down in terms of being able to ship new things. So the new features that we shipped ended up landing somewhere between like 6 to 12 months from kind of initial group start.
I had a question. Are there certain regions or countries where you're seeing more trends of certain security breaches?
I mean, we have a global product, so the stuff that we see, it doesn't really matter. I mean, we have deployments at each city in terms of operation teams, but in terms of our engineering, these products are sort of deployed globally. So, no, I guess the answer is no. We see attacks coming from all over the place.
In the beginning, when you're talking about diversity and building up the team, you said at the end of 2016, your team scored the highest in terms of cultural happiness and diversity and things as such. What do you feel like in building the team you did in order to get those statistics, and how did you retain and create that great culture?
Yeah, so the question, I guess everyone heard. So I actually have a whole presentation on that exact topic, which I'm giving, I think, next week or the week after in San Jose at the Women in Silicon Valley conference, which is super exciting. And I think that the short answer is we put a ton of effort and focus into being really deliberate about how we hired and making sure to expand the hiring pools and the people that we were reaching out to be sort of as inclusive as possible. And there was a lot of stuff that we did, I think, to try and once those people were hired, to then create an environment where people felt supported, where they felt like if they had a problem, it could be resolved, and they felt like they had a clear path toward professional growth, and they knew where they were headed in terms of the project work they were doing and sort of the expertise they were building out. So I think it takes a lot of care, time, effort, attention, focus. But I have, a lot more details to share on that too. But we're definitely not there, completely. So it's sort of just the first few steps of trying to get there.
Denali, will you be around today to talk about this stuff?
Yes, I will. Yeah, if anyone wants to find me later.
I hear there's a secret code to use Uber in Austin. Can you tell me what it is, please?
Unfortunately, I don't think either Uber or Lyft is operational here, but
Correct.
There is a really awesome service that I used called Silver Car, which allows you to book a silver Audi with your mobile device, and I'm so happy about it. We should just use that product while we're here.
I will point out that Uber Eats operates here, and I do use it almost weekly, so people with cars also want it.
Okay.
I think that's probably about all the time we have. In the absence of Dave, I'll say we have about a half-hour break coming up. We have an amazing coffee booth out here from Houndstooth Coffee, a local purveyor, and welcome everyone back at 10:30.
I have one announcement. Robin from Missouri